Hi, good afternoon. It's Mrs. Rinaldi.
Mr. Lucy?
Mr. Soboleski.
Okay, and today we're going to talk about measurement and sig figs. And the reason why we talk about significant figures is because we're limited by the measuring device, correct?
Yes.
And more?
Yep.
Okay, so we're going to just take different measuring instruments here, and we're going to talk about the number of significant figures you can get from them. Okay, Steve, you want to go first?
Yeah, so I'll take this first grad cylinder here. This one measures up to 50. Let me just get some water in here. And if we can kind of zoom the camera in. Let me go a little more. We can zoom. Okay, too much.
We love scientific.
Okay, so if you
Error
kind
here.
of aim the camera there, you can see that we have lines for 20 and 30, and then there's 10 lines between, well, technically 9 lines between it for each milliliter. So basically this measures to the nearest milliliter. What you need to do is measure, estimate one extra digit beyond that. So this is actually interesting. If I look at the bottom of my meniscus, I'm seeing it maybe just above the 26 line, so I might call that about 26.1. But technically, if I judge it to be right on that line, you really should add that 0.0. A good tip is this. If it's exactly on the 26 line and you're saying, should I call it 26, 26.0, 26.00? Imagine if it didn't fall on that line. If it fell halfway between, you would call it, 26.5. So you would now match that same number of decimal places if it did fall on the line. So an estimate for this could be 26.1, 26.0, 26.2, something like that.
Okay. All right. Let's change it. Let's change it up. So remember that it's just all the digits known with certainty plus one estimate. So always look at the tick marks there. Go ahead, Jim.
Okay, you ready?
Mr. Lucy.
That's okay. So what I see here, I know exactly where the 4 is. I know exactly where the 5 is. So as I count up, is that better? Ms. Dulimer, is that better? Can
That's
you see?
perfect.
Oh, it is? I can see the numbers? Okay. So I can see now I know where the 4 is. I know where the 1 hash mark after the 4 is, so that's going to be 4.1. The next hash mark is going to be 4.2. So I have a space between those two, and as Mr. Soboleski says, I'm going to guess at that space. So I can get to 2 places after the decimal. I determine that even before I take a reading. So now following the same protocol, getting down to where I can see the meniscus,
Yes, look at eye
Right.
level. Eye level.
and my old eyes, so I'm going to ask Ms. Dulimer to tell me what that is, because I really can't say. What is it? You think it's 6.5?
Yep.
6.5?
That
0?
looks like 6.50 to me.
Yeah.
Okay.
And make sure you go out to the hundredths
Right.
place.
So that'll
Very
be
important.
so that number is 6.500, right? Now the last thing I want to
Careful.
Yep.
We got to make sure we get the right number. So if you judge it to be on the 6.5 line, it should be 6.50.
Right.
Leave it there. Oh, I
Yeah.
misheard you.
No, that's good. So that's okay. It's a good double check. So the hardest thing we can give you, before I turn this back over to Mr. Rinaldi, the hardest thing we can give you for a measurement is when it is exactly on the line. Because if that's exactly on the 5, we as chemistry teachers see the answer 5 milliliters, we'll see 5.0 milliliters, we'll see 5.00 milliliters, we'll see 5.000 milliliters. Only one of those is correct. So in a math class, 5 is 5 is 5 is 5. 5 is not the same in a chemistry class. So this would be 5.00 milliliters, and that's reiterating what Mr. Soboleski said. So I determine how many places I can get after the decimal, and then when I do my reading, I make sure that anything on here, including if it's right on that line, goes out to that same number of places. And again, 10 milliliter graduated cylinder, 2 places after the decimal.
And
Fantastic.
it's even worth it, like when you first pick up your piece of glassware, like if I'm going to be using this to measure, let's say 10 different things, you can just look at this and judge how much you're going to read, how many digits each one's going to get. So like looking at this, let's see, I have 20, 30, 10 lines in between. So these are milliliters. So what that means is every single number I measure with this is going to be one step beyond the ones or the tenths.
Right.
So every single reading I get with this is going to be some number point something. So like 1 decimal place. And then you could just remember that for the whole lab.
Okay, and also remember, think about the diameter. The thinner the diameter, the more precise the instrument, okay? The more graduation. So look at the diameter of the 10 milliliter graduate compared to the 100 milliliter graduate. And you'll just remember, you'll start to use these instruments more. So they'll become second nature to you, okay? So let's keep going. Let's look at pipettes. Now, you probably won't use this year in chemistry. It's used more often in AP. However, we expect you to know how to use the scale. So if you look at this once again, what does it go up by? Okay, the smallest tick marks is tenths, correct? Tenths. So therefore, you can measure out to what, guys? Hundredths. Oh, they're so good, aren't they? Wow. Okay, now do the other pipette. This is really interesting.
This is my favorite pipette.
Hint,
because
hint. Might be on the assessment.
Yeah, this is 0.1. Put it down here?
Yeah.
Okay. This is 0.1. That line is 0.1. That line is 0.2. So that line, that first line you see there will be 0.11. That's 0.12. So this scale can give me 3 places after the decimal. So if it's right on that line, it'll be 0.200 milliliters.
Right, it measures out to the
Thousandth
thousandth
place.
of a milliliter.
And the only way you know that is if you look at the scale
marks.
prior to even doing any measurement whatsoever.
You have to leave space for that last estimated digit, okay? So you want to talk about not the graduated cylinder. Let's talk about the beaker.
The beaker? Sure.
Okay.
You do a beaker?
Okay.
Mrs. Rinaldi, sorry.
Sure. Here's the beaker. This is a 100 milliliter, actually 140 milliliter beaker. And what do the graduations go up by? They go up by tens, 20, 30, 40, 50, 60. So you should be able to measure by ones, but
Yeah,
yeah,
but
it's not really
no,
not
yeah,
in this.
right. Yeah.
So even though it does go up by 20, 30, 40, I would never use a beaker to measure,
No one
okay? They're not measuring instruments. They're used to basically take some acid from the hood, and then you're gonna pour it into a graduated cylinder, okay? So even the smaller ones, they're not used to measure. Not great measuring tools, okay? Talk about the burette.
Burette, much like a ruler.
2 types of burette
Right.
here. This is the one that we're gonna use more often, right?
This is the 50 milliliter burette.
Right.
And just like the ruler has a scale, the thermometer has a scale, all of these have a scale, we have to apply the same knowledge we have here. So I look at this burette and I see where 15 is, and I see where 16 is, and I can see a mark for 15.1, I see a mark for 15.2, and I see a space between there. So I can get 15.1 guess 3. So 15.13. So from here I know I can get 2 decimal places. So any reading on here, and again, my favorite reading is something directly on the line. That's not 12 milliliters, that's 12.00 milliliters. So this is a 50 milliliter burette. The volume is distributed by difference. We'll talk about that later.
Right, it's
And then
dispensed.
It's dispensed, and over here we have a
Because the
100
numbers go up.
milliliter burette. Want to do that one, Mr.
Yeah,
Sobleski?
so
This is different. Watch out.
Right, so let's see. This one's tricky because it's not on a perfect scale of 10. We're going up by, well, I guess down if you look at it this way, by 0.2. So since it's 0.2, we really can't estimate the 0.1s, correct? So this
Correct.
would have to be kind of measured to the nearest single milliliter.
I still think
mean to
the
the
estimate
tenths.
would be at the
I guess
tenths place.
you know the one you're going to be measuring to the tenths here, but you're not going to go
Absolutely.
beyond that.
Right.
Okay. So this one's a little tricky because it's
Watch out,
0.2s, not
watch out.
0.1s.
Okay, now the next is the volumetric flask. We will be using this when we get to our mystery lab, the clue game, the murder mystery lab. So you'll be making up solutions. Now, notice there's one line here. There are no graduations. So what do? You look at the diameter and you compare it to the closest diameter. It compares to this diameter on the burette and also the diameter of the 10 milliliter graduated cylinder. So this is a 100 milliliter volumetric flask. Since this measures out to the hundredths milliliters, tick marks go up by 0.1. This measures out to the hundredths milliliters. This will also measure out to the hundredths. These are very good measuring tools. Okay, so that's 100.00 milliliters. And I love how everyone's talking about units. Remember, we're in chemistry class. We have no naked numbers. Numbers have units. If you don't have a unit, you're going to get the answer wrong. Sorry. Maybe I'm being a little harsh.
No?
Oh, no.
Should we do the Erlenmeyer?
Yes, Erlenmeyer, last one.
Okay, this is the last one. These two are the least expensive pieces of glassware that we
Good.
purchase in chemistry because they're not very precise. So this is like, Ms. Rinaldi might say, or Mr. Sobleski, do you have about 100 milliliters of acid? I go, yeah, I have about 100 milliliters of acid. I don't know how much I have. I would never say 100.00 with this. This right here, notice the flat bottom and the narrow top. If I need to store a solution overnight, I'm choosing the Erlenmeyer because this has a very wide surface area, and we don't want to put parafilm over all of this. It's just a waste of parafilm. So the flat bottom makes that very stable, more stable than this, and the narrow top, easy for our parafilm to go over, or a stopper overnight to
Less
eliminate that.
vibration. Yeah.
And then, so what you have here is an estimation scale. So we even talk about this in chemistry. Notice how the shape changes. So the shape of the scale changes. I would never get a volume reading from this. This is like an estimate. I have about, if it's up to here, I have about 150. I would never say 150.00 milliliters. I have about 150. So least accurate, next to least accurate, and then we start to get into the sizes here. One last thing that I'll say is be very careful. Don't assume that all graduated cylinders are going to have that same level of precision. Notice all of these are different. So every time you use a graduated cylinder, you have to look at that scale.
Okay.
All right?
All right, that's it for
That's it for
measurement.
measurement.
Good introduction. Good luck on the quiz next week, which will have these different instruments on it, and you'll have to read the scales. Okay, take care.